We are going to be solving exponential functions, and we are going to go through a series of guided practice problems. You can have your calculator near you just in case it is helpful. So just so you know, they do switch up the variable, but if you want to change the variables into x's, if it makes more sense to you or it's less confusing, feel free to do that. So I know some students prefer x's, so I'll switch that to an x. You're not required to do that. So my goal is to solve right now. My goal is to solve for this variable. So what you need to do is you need to find, kind of like when we solved rational equations, we found common denominators. We're going to find common bases. I need these to turn into the same number. They have to be equivalent forms, but the same number. So if I switch 8 and I turn it into a form that has 2 on the bottom, it would turn into 2 to the third. Hopefully at this point you recognize that 2 to the third is the same as 8, correct? When the bases are the same, just like when we used to have the denominators the same in rational equations, we cancel out the bases and we solve the tops. So I divide by -1, divide by -1, x equals -3. This problem is done. Going on to number 2. So 6 and 36. How can I rewrite 36? 36 can be rewritten, and by the way, I'm going to change the p into an x. Not required, just for some students it makes it a little bit easier. So rewrite 36 as 6 squared, still an equivalent value. Okay, bases are the same, cancel out the bases, and you have -x minus 2 equals 2. I'm going to add 2 to both sides. Divide by the -1, and x equals -4. 1 to 5, how well do you understand the first two? 5 being completely. Okay, good. Let's go on right now to number 3. How do I rewrite 32, Roger? 2 to the 5th. Nice job. Cancel out. 2, and I'm going to switch it to an x, but again, you could leave it as an r. 2x equals 5. Divide by 2. X equals 5/2. It's important for you to practice these problems with speed like you would have to do in an ACT or SAT exam. So looking at number 4, I'm going to give you 30 seconds to start on your own, and then I'm going to begin. Please check your answer with mine when you're done. Look at my answer. I'm going to give you 10 seconds. Check with your partner to make sure that you both understand how to do 4 correctly. See if you're understanding. Roger, are you understanding? Okay, let's go on to number 5. 5 is already in an easy form. 3x equals -3x. Okay, this gets a little confusing. You ready? So I'm on to number 5 if you're not there. I already get to cancel out the bases. They're already in the... Did I write something down wrong? That's okay. Good question. Okay, so now I have to figure out how can I cancel this? Well, I'm going to choose to add this 3x to the opposite side. Now nothing remains on the right-hand side, and I have 6x on the left. Divide by 6. 0 divided by any number is 0. Going to time you again. This time I'm going to count out loud. You have 15 seconds for number 6. Go. I'd like to just see if you could try to do these without a calculator. Hands raised when you're done. If you see me make a mistake, just let me know. So these problems do require work, which means if you hand in a homework assignment and you wrote the answer is x equals -2, I don't give you any credit for the whole assignment. Does it require much work? This is like 8th or 9th grade work, right? In terms of how many steps. Okay, ready? Let's go down right now to number 7 and number 8. Ready? With your partner, only choose one of them and only do one problem, 7 or 8. Then look up above and check your answer. So with your partner right now, choose one. You both will do the same problem together. Okay, does everybody agree with the answers I have? And I only asked you to do one. Does Amy disagree? Flip over to the back. Let's go on to some harder problems. Okay, number 9 is still looking pretty easy. So I get to cancel out the 5s. Negative 3x equals 1 minus x. Again, I'm switching an n and substituting an x. So I'm going to add the x on the right to the left-hand side, dividing by negative 2, and you end up with negative 1/2. That's just basic algebra. I'm not going to take time for you to do number 10. We already did a problem similar to it. We're going to look at number 11. Okay, so first of all, let's first examine this problem. The first thing I want you to do is I want you to recognize a base that we can use that will be similar on the numerator, the denominator, and on the right-hand side.
I just did a quick drive by. Good to see you, tight? Yes. Yes, I am.
Okay, anybody have an idea? What number should we use? What number can I keep those values equivalent to but have the same base? A 5. Nice job, April. So I'm only going to look at this number. Now this is different than what we've done, so please pay close attention. I'm only going to focus on the numerator right now. I can switch 125 and make it base 5 raised to the 3rd. Do you agree this is equivalent to 125? Now I need to put a parentheses behind that and write negative. Again, I'm going to switch the k into an x. Negative 3x minus 3. Okay, now I need to represent 1 over 125, and I want it to contain a base of 5. Brian, do you know how I can rewrite 1 over 125 with a base of 5? So you think 5 raised to the negative 5 would be negative 125? Nice job. So 5 to the 3rd is 125, and we want it to be the reciprocal, so we make it a negative exponent. So I'm good to go so far. Now I need to rewrite 1 over 5, again having a base of 5. Adriana R., what do you think the exponent's going to be to get 1 over 5? So what do I need to put up here so that when I would take this and simplify it, it would become 1 over 5? Can everybody talk to your partner really quick? 3 seconds, see if you guys have an answer. 1, 2, 3. Rodrigo, what do you think? It is going to be a negative. Yep, it is going to be a negative 1. Okay, now we're going to go back to what we learned about with exponents 2 chapters ago. And it really is a review from Algebra 1-2, but for many of you, you struggled or you forgot how to do exponents. When you have the exact same base and you're dividing, what do you do with the exponents? Subtract. Okay, so you ready? I'm going to write this thing out. Just watch here. I'm going to write this out. Oop, that's what's positive. And I'm going to subtract it from this. Okay, so 5 raised to this equals 5 to the negative 1. What do I get to do with the bases? Cancel them out because they're exactly the same. And now I want you to take this. I'm going to come off to the side, and I want you to take this and solve it. So I'm going to start by distributing this 3. And this gives me negative 9x, distribute, minus 9, 2 negatives makes a positive, plus 3 equals negative 1. Continue to solve for the variable x. Negative 9x minus 6 equals negative 1. I'm going to add 6 to the opposite side. Divide by negative 9. And x is equal to negative 5/9. Bless you. With all of these problems, you could always check to see that your answer is correct by going back up to the original equation and plugging in for the variable the answer that you achieved. Okay, please turn to your partner to ensure that both you and your partner understand number 11. Go ahead. We're going to move on to number 12. Number 12. Okay, think hard right now. I have a 32, a 32, and a 4. With your partner, now this is the most difficult part for many people. It's also the first step. How can I rewrite a 32, and a 4 having the same base? Turn to your partner. You have 15 seconds. Go. 1. Lara, what do you believe? Are you confused by the question, Miss Lara? Okay, so let me rephrase the question so everybody can hear it, because I'm sure others are confused. 1 second, please. Miss Lara, is there a number that I can raise to a certain power and I end up with 32? Perfect. Did everybody hear that? 2 to the 5th. Do you guys agree? So this can work with the 2. This can work with the 2. Can I rewrite 4 with the base 2? So she's right. So I'm going to rewrite this as 2 to the 5th, just like Miss Lara said. Make sure in back you have what already existed as the exponent. Okay, Miss Alma, how do I rewrite 1 over 32 having a base of 2? Good job. And 4 can be written as 2 squared. Fabio, when you have the same exponent and you're multiplying, what do you do? Let me rephrase that. I said this wrong. When you have the same base and you're multiplying, what do you do with the exponents? We are going to solve, but there's an operation you have to do first. So over here, when we had the same base and we're dividing, we subtracted. Now when you have the same base and you're multiplying, you add. Great job. So I have 2, and then up top I have, so I'm going to multiply. 5 times 3 is 15, so I have 15. I'm just going to change it back to an x. 15x plus negative 5 equals 2 to the 2nd. A common misconception, sometimes students want to go 2 times 2 and put a 4 in the bottom. You keep the base the same and you add the exponents. Okay, cancel out your bases. And I have 15x plus a negative 5 equals 2. Add 5 to the opposite side. Divide by 15. And x equals 7 over 15. Go on to your very last one. You have 1 minute with your partner. I need to hear mathematical discourse occurring between you and your partner. 1 minute, and then look up here if you need any help. I will begin in 1 minute. Go. Hi, Blue Jay. So, Blue Jay, here's your problem. We're just finishing up. I'll explain to you a little bit what we're doing, okay? April, you're understanding the lesson? Roger? Erica, are you understanding the lesson?